All right. Welcome back. We're working on our Atari 2600 emulator. I think that I've got my Arch Linux set up, doing pretty well. So hopefully we don't have any lag. Cool. Cameras on screen. Hopefully will not freeze in the middle. And maybe I can get some refactoring done. So today, I'll just sort of go over what we did last time. We implemented timing. Let's see what our diff looks like from the last commit. Yeah, we added spin sleep for timing. Let's see. Cool. We made some pretty ugly timing code here. So that's part of what we're going to work on. Yeah, we've got some like time, total cycles, stuff like that. But the fun thing is that now, let's see, run cargo run. We see that we have how much time it took, which is, let's see, 2.12 million nanoseconds, and how many cycles it took, which is 2,500. So if we open up our calculator and we do 2120702 divided by 26, right, we get 840-ish nanoseconds per cycle, which is pretty close to what we were looking for. Actually, we can take a look at what we're looking for. 837 nanos per cycle. So I think that we are... Why is it longer? I'm not sure. That may just be... It may just be error at this point. So I'm not going to worry too much about it. So let's take a look. I have a couple ideas on how to deal with this sort of mess we have here. So let's go to our main. So we have this kind of... Let me turn down the music for me a little bit. All right, so the basic logic here is pretty simple. We are grabbing a duration from nanos that we're doing this every 40 cycles. The reason we're going to refactor is because there's also a nice bug here, which I can demonstrate in just a second. But we are saying whatever the chip cycles were before, subtract that from the number of cycles now, and if we've run more than 40 cycles, so instructions that add up to 40 cycles, then we're going to do this code, which basically sort of sleeps our thread and for the appropriate amount of time. So we have the cycle time, which is duration from nanocycles run times 837, whatever our elapsed is from when we took the instant. In this case, it's right here. How long we should sleep is our total cycle time minus our elapsed time minus any run over, which is basically any extra we get when we do our sleep. Our sleep is here. We take an instant before and after. That run over is set basically if it takes longer than we asked it to, and then we set previous cycles to chip cycles. So I can show you the error here. If I go... I'm waiting for... Do need to figure out Rust Analyzer. For some reason it just hangs for a little bit there. Yeah, so we have an overflow when subtracting durations, which is actually, let's see what the I've never messed with main 159. Yeah, it's right here. Cool. So basically, what's happening, and we can print all this stuff out and look at it, but is occasionally this run over is really long. It seemed like at about 40 here, it stopped happening for now, but that's not a guarantee. So there's definitely a bug here. So there is a. Let's go over there. We'll restore these pages. Actually, let's not restore those pages. There might be something there I don't want there. We're going to open the rest docs. Then we're going to look for duration. You can see in our duration, there's these functions here. I'll just jump right to them called checked add and checked sub. Basically, it's an error to subtract to add over duration max, which we're not getting anywhere close to, but under 0. So if we subtract, so the normal subtraction is not checked, but basically check sub gives us an option. So I would like to test this. The problem that I came across is that it's pretty hard to sort of test duration stuff, but this logic is pretty straightforward. I think that I'm gonna basically I'm gonna use a mock. Fake clock is I think what I'm looking at. Yeah. Version 0.31. So fake clock is a crate that gives you essentially a bunch of things that are on that instance, like now, elapsed, and you can actually just set the time. So we can test all of these cases and abstract it away from our chip here. So we're going to do this kind of in place, but just at the bottom, because we'll move this all out eventually, but we're going to make we're going to make a struct timer. I'm trying to think if this needs anything implemented in it. I don't know yet. So let's never construct or never used. Import timer. So let's test newing it up. This is where we sort of scratched out our algorithm before. I might as well leave it there for now. Actually, it's not really in this part. It'll be up here. Everything get formatted. consider adding a config test to the whole, to the containing module. Why would I do that? That's interesting. So I'm going to map my key to write this and run tests. Make sure I have this all set up. Yeah, I'm not sure why it's telling me to do something different, but maybe it's just because I don't have anything here. We'll new it up, so we'll just take a timer. We'll call new on it. And let's assert. Doesn't really matter. We're just going to say for now we're just going to so it's telling us that there is no associated item called new. We might actually just nuke this test eventually. So we'll this will be a public function. New. I don't know that we need to take anything yet. We're just going to return timer for now. It needs to return self. So the function is never used. I guess it doesn't count in the tests. Assert is a macro. Test is running. Awesome. So then let's look at our sort of instantiation stuff for this timer. This is all this. So this is like a bunch of state that we can take, although I don't think we need the cycle stuff. So I think we just kind of need to know how much time let me think about this. So if I want to, so let's see how I want to use this. I want to do like let me equals timer new. I want this to know about like the instances and stuff, like instant now. I think I can do that pretty easily, and then I want to be like so I actually want to be pretty explicit. I think I want to say a timer start cycles I don't want to know, but cycle time I do. So I'm going to say like this is all sort of for outside. So and then I don't really care about this. And then previous cycle is being set from previous cycle. Okay. So I think I can kind of just replace all of this. We're going to have a bunch of compiler errors because this is all wrong. With timer. So it's not really sleep for. It's like should sleep. I do have my, yeah. For cycle time. How about we say like pause for cycle time, which doesn't exist, and then we do our previous cycles equals cycles. So I think that gets us somewhere close. So we have a start and we have a pause for the test. So start a timer. So some of this we don't need mocks for, so we're just going to go ahead and do this. So we're going to do timer.new and timer.start. And then we're going to assert that, maybe we'll assert equals timer dot, probably just pass an elapse through. Timer.elapsed. We're going to do 2 calls to elapse. We're just going to make sure that one's bigger than the other. And I think that should. So we're going to say assert that timer elapsed is greater than earlier. Well, so what do we have here? Time and or start and elapsed are different, so we're gonna do start takes a mutable self, I believe. Sets the self dot instant equal to instant dot and I think I can just take a we'll have an interesting situation here. I think we might start with an instant. You know what? We're gonna get rid of this new. And we're gonna return self from the start method. And we're just going to new up and start the timer at the same time and just be explicit about it. So we're gonna do timer. So it's saying we don't know new. So instead we're going to do start. No method elapsed. Once now. Remove this semicolon. I don't need that. Elapsed not found. Okay. So takes a reference to self and returns a duration, I believe. And that'll just be self.instance. It's a method call. Awesome. All right. So I would actually. I'm sort of wrapping an instant, but I'm going to be doing more than that. Otherwise I'd make this like a new type pattern. But I think for now, I think this is good. Do I not have assert equal to? Let me check the Rust docs. Greater. Oh, because it's just assert and assert not equal. Okay, so I'm just gonna have to do it the old-fashioned way. With just an assert, and we'll say that elapsed is greater than earlier. So I should be able to run that test, and that should. Oh. Okay, that's where I wrote it up here earlier. I should kind of say. We're going to quote out the rest of that. While we run our tests. Start a timer works fine. Okay, so that's working as expected. So the next thing we needed, in fact, we can just show what we need by undoing some of that stuff, is we need this pause for function. So let's for. Hey, so pause for is where we're going to have to start getting into like what do we do about timing stuff, but we'll say so cycle time is going to be a duration from nanos. So it's going to be So we're going to say timer start and then timer dot pause for duration dot nanos. We'll do it for, let's do it for 10 times what we would, 837, 8,370. So it's saying duration. So it's saying, okay, you have duration, so now I need pause for. It's going to look like this. And we need a dir, which is a duration. We're going to return nothing out of this. We're just pausing. I'm thinking we can have a reference to a duration here. Cool. So what are we going to do here? We're going to do basically what we had up here in our logic. Interesting that it thinks that previous cycles is never read here, but it is. Why didn't seem to have a problem here? Oh, because yeah, okay. Because I reassigned it later, which is fine. Okay. So now run over time. Okay. Remove the mute. I think pause for might need to be mute. In fact, I'm pretty sure it will. But we will get there when we get there. Uh-oh, where's my... So, we'll say... our lapsed is our self dot. I changed that back, and that shouldn't be instance. That should be instant. And I don't know why my brain said that should be instant. Instance. Function's never used. So we can actually just do self dot elapsed. So we should sleep for the duration minus whatever is elapsed minus a run over, which we'll keep track of here. Run over. So duration. So what is it saying is wrong there? Missing run over, that's fine. Duration. 0. Uh, 0. Doesn't like this subtraction. Maybe I need it to be all... fixing a bunch of compiler stuff. Let's actually see what that particular error is. So it's saying, yeah, don't use sleep. Cannot subtract a duration from a duration. Do I need... Does duration not implement... I need to pass it. Let's see. So impl... Yeah, so it... Yeah. So what does it represent, or a clone copy? Okay, so I can't do it with a... Can't do it with a reference to duration, but it does look like it implements clone copy, so this will do. Add this really bad abbreviation to our thing. We're not using sleep here. We will in a second. Cool, and then we'll go change our implementation. I want us to remove a lot of stuff there. That's fine. Let's actually run our tests. So far we're doing good. Let's see, what's the next thing we want to say? So I think we say after so we're sleeping for 8,370 milliseconds, or 8 microseconds. Let's actually make that significantly bigger. What is this? Probably don't want to open that up. Think so. Now I'm curious. Turning off my desktop audio. That is completely off topic. Cool. Okay, so we'll do it for a little bit, like more like 83 microseconds. And then we're going to say earlier equals timer dot. And so then we're going to say, okay, so we're going to say that it's not just that it's greater than earlier, but that the difference between the two, so the difference between whatever's elapsed after we paused and whatever is we got earlier is greater than from nanos that I think should fail. Yeah, so that's because we didn't sleep long enough. In fact, I wonder if we can print out how long we did sleep. Later equal. Later minus earlier. Yeah, I don't know that I can actually print in a test, can I? Let's panic with this. Let's see what it says. It's 249 nanoseconds, which is far less than our 83,000 nanoseconds. So we wanted to pause for it, right? So I may not actually need to pull a time mocking library in here. I think that I can. Actually, yeah, let's see if I can clear this off. One second. Clear. So maybe it's a buffer command. So there we go. Get that YouTube link off the channel. Cool. So actual time. Awesome. Okay, so sorry about that little break while I figured out how WeChat works. So we're going to keep doing this stuff. So we're going to say Why am I doing this? I'm just gonna make a new instant. We're gonna sleep for how long we should sleep. Self.runover and self dot. We're resetting the instant. And it's saying I can't do this because it needs to be mutable, which is easy to fix. We'll take a mutable self and pause for that amount of time, and then need to say that that's mute. Yep. We'll actually use later here. Overflow and subtracting duration, which is actually exactly what we want to sort of deal with, although I'm a little surprised that that's the case. So instead of assigning to self here, we'll say panic should sleep. There's probably a better way to do this. Nobody's here to tell me what to do, so I'll just do it this gross way. Actual so yeah, this now need a parenthesis, easy enough. Need a bang for the panic macro, and that's unreachable, which is fine. Should sleep 43 so that actually shouldn't have failed. That didn't fail because the run over. So I think I got this. This is should sleep. No, because the lapse will be greater than. So it should sleep for 83 microseconds, which is exactly right. Our actual is 392, so that sleep didn't work. That's strange. It's almost like sleep isn't working. So let's do standard thread. Make sure that spin sleep's not doing something weird. What? I think I'm missing something here. So that... So, should sleep for... I got my brain all mixed up. I should sleep for 83.5 microseconds and actually slept for 183. So that's with the... I believe that's with the standard thread sleep. Let's see what happens with the spin sleep. Yep, okay. Should sleep for 83.57 microseconds. The actual slept for 83.9 microseconds. So then I shouldn't have to panic. Now that elapsed minus should sleep. So that shouldn't panic. Okay, so that still shouldn't panic. Let's get the backtrace on that. Panicked. Pause for assertion failed. $247. Why is that different from what's here? Okay, so that's the same panic. Let's see where it's saying that is. Test pause for 247. And then there's 242. Oh no, okay, so that's... I've reset the timer. Okay. That's fine. I actually don't want the timer's elapsed time. I want my own. So. And then I want I think that probably fixes the test. Awesome. So what I want to do, actually, I may need to mock the sleep function because I want to check for when it takes a really long time. Yeah, okay, so then we're gonna go grab our one second. Putting my phone somewhere where I can see it if I need it. So we're gonna go for fake clock is what we're going for, I believe. Yeah, so it's, I think I saw 031. Zero. Sorry, I was just thinking about how I was going to do this since these are all internal. So I'm going to need to like mess with the function when I want to get that run over. I think I can do it myself. Yeah, okay. I think I can do this. All right, so what I'm going to do is a little bit of... So out here where I get... So I'm actually going to pull out this whole declaration and do use standard time. What I'm going to do is make that and that should actually break everything, right? Because I'll consider importing struct instant. Yeah, because it's gonna say, okay, so I actually want this to be config, not test. So what's it gonna say here? And so then I'm going to say config test I'm going to have to do this with some sleeping and stuff. Okay. I think that I'm good though. Fake clock as instant should get me. So let's see what happens. I think something's going to go wrong. Yeah. Assertion failed. Yeah, because the timer's not moving forward at all. So that is fine. config test, config not test. 1 second. We need to do the same thing for sleep. So we're going to do, just going to do that in the same place. We'll move all this out into a different module pretty soon, but not test. We're going to use spin sleep dot test dot sleep, and then when it is, we're going to make our own function sleep. So which takes so we're going to need to use the duration as millis. Okay, so this takes a duration, doesn't return anything, and we're going to use fake clock. Extra. I think that should be the implementation for our sort of mock sleep. The good thing is that this won't take any time. Associated function with a similar name. Did I spell millis wrong? All right. What doesn't it like about that? Maybe it'll tell me better. Expected a U64, found a U20. But yeah, I don't care if it panics, it's just for a test implementation. So do I think I need... I may have gotten myself into more trouble than I can handle here. Let's print some stuff out. So what's the first test that's failing? It's saying, I think pause for is going to be overflow and subtracting durations. So advanced time. I wonder if it's not sensitive enough to know the difference, but we can take a look. May not be able to do this very easily, so I'll give it another shot, but so test started timer, panicked at 2:46. Something inside 2:46, 2:49. Print off our earlier. We're actually going to panic it since we can't see the print output earlier. And we'll need later in the same later. Or just timer dot. That's fine. Run that test, see what's going on. Okay, so syntax error, that's cool. That's cool. So we're saying that, I see. So for this, we just need to advance time. So we can use the same thing. So let's use fake clock. So we'll say, yeah, before, and then if we advance the clock, can we actually just use advanced clock directly? No, okay. So we'll advance the time by 10 milliseconds. Why don't we? Okay, we have an overflow when dealing with duration. So let's take a look at exactly where that is. Main 258. $2.36. So what's going on here? I feel like they should be exactly the same. But let's see. And should sleep. And now dot elapsed. See what that panic does. Elapse is 0 nanoseconds, so it should sleep for 4. So it should be using this version of sleep up here. This got all messed up, didn't it? So then it should be advancing time. So let's... Yeah. So I may not actually be able to use these in different scopes. Panic, what else? What? Oh. Elapsed. Oh no, I need to new up a fake time to get elapsed. Returns how much it's the creation of self. Return to say a fake clock. Okay, that actually makes our life a little harder here. Maybe it advances time globally, but I'd need to hold on to an instance. So do I need to do this? I have one. There's an article out there that helped Rust fake time. see if there's anything about how to use this in here. Great. Okay, how did I get that? Oh, it's rust, mock, sleep. This is fun watching me. Nobody's watching this, so it's fine. Rest, test, sleep. Okay, maybe I'm going down it wrong. So if I do... So we saw that elapsed was 0, even though we're advancing time. Let's take a... We might just need to look into the source code of that crate. So... Advances the thread local fake time by the given amount of milliseconds. Maybe it's not... So... We know that pause for is calling that sleep because it panics there. So we're going to do... Let's just take a look. So if we do that, just do now. All right, so nothing's elapsed, right? Because we haven't advanced the timer. So if we use fake clock here and we clock I may give up on this by 10 milliseconds. We should get something different now, right? 10 milliseconds, exactly what we're expecting. If we instead sleep for duration from millis 10, we should be using that sleep function that we created, and we should be 10 milliseconds. So what is the difference after we pause for, whoops, okay, we're in here. So let's get rid of that. Can't do that yet. Okay, so So I still should have no time elapsed. It should be a 0 millisecond. Zero nanoseconds. Perfect. So then I should be able to do that after the sleep, and it should not be 0 nanoseconds. It still is. What if I put the use fake clock in here and do fake clock advance time 10. So that does work. So, but sleeping doesn't. Why not? That's too short. So what if I do 10? I may have to test this in longer durations if this thing isn't sensitive enough. From millis. Yeah, that's the problem. Okay, all right. So then that's fine. We'll just do that with just a much higher time. Apparently, it just it's millis as U8. Okay, so panicked for, okay, there's a panic somewhere. Yep. Still here. So what is... it's not greater than it's exactly. That's why. Okay, so let's advance time a little bit. So use fake clock. Actually, we have that. So fake clock. Advance time by 10 milliseconds. Right. So. Test or passing. We'll just put a big note on this one. Fake clock does not support times less than 1 millisecond. These times are unrealistic for our use case. And I won't worry too much about that. So now we can drive out the sort of bug that I know exists. So pause for too long. So it'll be all the same, except that when we advance time, we're going to advance time by more than we waited for. In fact, we can take a look at exactly what that looks like. So it's whatever we slept minus should sleep. It's actually going to be... It's the run over we want. So we want our run over to be big. So we can actually think we can just set that up. We want to do that from the outside. So we do this whole thing. We advance time. So our run over should be 10 milliseconds here. In our case, why don't we make these smaller to be manageable? So we'll pause for 10 milliseconds. We'll advance time 20 milliseconds. Then we're going to pause for, again, 10 milliseconds. Same timer. Pause for too long. Test. This is a test. And then we actually should just have a panic here. Yep. Overflow subtracting duration. So basically what happened is that we had this run over from last time we ran this thing, which is basically, we're going to just separate this out, which is set here when it sleeps for longer than it should. Now, if it sleeps for longer than it should, then the next bit should, like, ends up running, then this is negative. So we actually need to do a little bit, we need to fix this error first. So we'll use something called checked add. Checks the sub, in fact, which returns an option of the subtracted duration. So basically we're going to do, we could also do a saturating sub. Let me think about saturating sub. Sub returns 0. So we don't have to handle the case. Let's try saturating sub for right now. So duration minus elapsed. I'm trying to think if that's ever a problem. So our duration, we pause for some amount. The actual elapsed time, if that's too big, we have a problem. I think we're actually going to panic there. That's a big problem. If our execution of the instructions is taking longer than a 45-year-old chip would have executed them in, then we have a real problem, and I think I'm just going to blow up. So let actual but I want a better message than that. So we'll do sub, and we'll just expect. Took way longer than it should have. Something is very wrong. We don't need fake clock there anymore, so actual saturated sub, and that should prevent the error. Now we're gonna have to think about what happens. What is it saying there? Saturating. Okay, so we actually got that error, so pause for too long. Okay. So it's saying I don't need that. So I'm typing this. Okay, so it's saying that basically let me think. I think what it's saying is that my duration minus my elapsed time. Let's take a look at that with backtrace. Timer pause for 233. Too long, 277. So it's actually the second one, so it's because I'm advancing time a bunch. Okay, so I'm testing something different than I actually thought I was here. So I'm actually testing that duration minus time. So I actually need to test for the run over. The run over is going to be hard. Yeah, okay, so I actually need to set that directly. Just make it pub for now. I don't love this, but right, that's not there. Think of a way to get rid of this public here. So we're gonna do timer run over So we're going to say that our run over is 20. Because before we were actually just saying our execution took a long time. We're just getting us somewhere close, but not quite right. So it's passing. Let's make it fail again in a different way. Yeah, okay, so overflow and subtracting durations, which was the error that we were getting, but we're getting it for the wrong reason before. But now that we're doing a saturating sub, we should sleep for 0. Now the question is this the correct behavior? So let's think about this. We have our little... I thought I saved it. Yeah, we have our... So we calculate our run over. So we start, we run some stuff, elapsed. Sleep should have taken minus elapsed minus our run over. If our run over is negative, that means that we need to do like a fair amount of catch up, which is why I think if the whole thing is negative, okay, so then so I think we need checked, because I think we so let's think about what this means. Say it took 10 to run. So we have a 20 run over. Okay, no. We had something. Took 10 to run. It should have taken 5 to run. So 5 minus. So it should have taken 10 to run. It took 5 to run. And we don't have any run over to start with. Right? So then that should output to... So it should sleep for 5. Right? But then when we sleep for 5... But took, let's say just something big so we don't have to think about it, but took 50, our run over this time around is 45, right? So when we go to do this again, let's say it should have taken 10 but took 5, and we minus our run over, then we're negative, and we should sleep for 15 negative 30, which isn't possible. So we sleep for 0. What happens if we sleep for 0? Good question. So then we sleep for 0, but took 0. But then we have this problem where we are like skipping ahead. So then I think we should pull from our run over if there is any. So we have 30 of run over. Let me think about this. So we have 10 minutes to, or 10 that we should, it took 5 to execute. Then we should take 10. So we should sleep for 5. It took for another 45. So we should sleep for 5 again, but instead I think we should just take it from our run over if our run over exists. Does that make sense? So like, if in this case, so instead of that it's -5. So then our should sleep for 0, but then our run over is now 40. Yeah, I think it's just count down our run over. So whatever the difference is should count down our run over. So let's take a look at what that might actually look like. So run over equals elapsed time to now. That should sleep. So we actually want to do a checked sub. So we're going to we just won't sleep if it's 0, right? No, if we check sub. If it would be negative or if overflow occurred, right? So so we don't know if it's 0 there. So we can still sleep for 0. I think that's fine. I should take a look at it. I'm not seeing this code in here anyway. This might be internals. Okay, that's not what I wanted to see. So we can actually do this a little bit differently. Let's say like if self dot run over is greater than actual, then we can safely, or then we if run overs is less than actual, then we can do sort of all of this. So else. So otherwise we're not going to sleep. And I didn't know whether sleep would of 0 would do anything. Start time duration. I'm not sure exactly what that is. I think it's okay. So otherwise we're going to I don't know why that's weird, but we don't have to worry about too much. We can just do self dot run over minus equals minus equals yep. What doesn't it like about that? Let's see a better error for that. Found an option. Oh yeah, so we don't need to do check sub. We can leave it to panic, because I think we've already done the check. So then I think our test should pass. Cool, and if I am correct about this, this is some pretty ugly stuff, but we'll move it out in a second. If I'm correct about this, I can do our old I don't actually think we need this. I think we need previous cycles. Okay. Go back to 10 and we'll see what happens here. Cargo run. We got to our instruction. Let's see if make sure our timing is still good. So we'll go to our DC. Nope, we'll go to BC. Huh? 2129336 divided by 2526. 842, which is looking pretty good. It's still a little higher than our target, but I think we're okay with that. So let's move that stuff out into a new module. timer.rs. Take all these tests. We'll take the timer. Take this. We'll take this stuff. Timer. Use timer. Timer is private. Let's see, is there anything else that it doesn't like here? Yeah, it doesn't like total time. It's using instant. It's really just for debugging right now, but we'll keep it around. So we want to bring back instant. I think it should. We'll skip in here. All right. Timer is private. Pub. Need duration. I need duration all the time, and it's the same no matter what we do, so we can just pull that in globally. This code is inactive, that's fine. Note. I think we're in good shape. Let's make sure all the tests run. Everything runs all right, and then let's make sure we get to the same place with our cargo run. Yep, instruction 8A, that's where we were last time. So we have actually succeeded in rewriting my nutty code into something tested and reusable, and we fixed a bug. So I'm gonna take a 5-minute break. I'll be right back. We're back. Let's commit what we did. Push it, and then we have one quick more refactor, and then we're gonna get into implementing some of the chips or sort of hardware that's memory mapped into the memory mapped into the chip on the Atari 2600, because we're gonna get into some like cool timing stuff. Let's have one quick refactor I want to do first. Hold on, I'm gonna drink some water. Remove 2, that's my old nemesis. Add, we're gonna add source timer. Got our fake clock package. got our timer. Cool, we were able to drop our number of cycles to 10, which is, I think, a much more reasonable number of cycles to run at a time. I think we have to worry less about what'll happen if we have too many cycles and we go over a boundary where the screen should have drawn and stuff like that eventually. We've got a nice API for that. It is oh, this is the whole file. Okay, I was like, why is it just showing me the test? Okay, refactor, timer, fixes, and underflow, panic when sleep takes too long. It's test cases. Great. So then there's one more refactor I wanted to do. We'll get out of here. Which is just a little bit. So eventually I'm going to be moving sort of all the logic that's out here about like instructions and like looping everything's in cycles. That's out in the main function. Into something involving the chip itself. I want to do that a little bit at a time because I'm not entirely sure how to do some of this debugging stuff. I could just throw it in there, but this concern is somewhat like somewhat orthogonal to the concern of the instructions. In case you don't know, what the debug does is print a button. It apparently just panics somewhere. Okay. It probably doesn't play well with... Oh, I see. There's like a debug. I'll have to look at debug stuff again at some point. Because that didn't... error out, but I'm guessing it has something to do with the timer. Yeah. So we could actually do something about that right now. So this is the only time we're doing timer stuff. I already did that, so else this is begging for a better design, right? But we will get there one piece at a time because I'm not entirely sure how I want to do this. Since the debug stuff has to like pretty like intimately know how to print this thing. We'll see. And there it goes. So the debug basically shows you sort of what's happening, like where the program counter is, where the stack pointer is, like it stopped somewhere 8A, right? Cool. And what I was gonna do here was just sort of switch, like a really small change that sort of switches around the sort of control flow here, since like it doesn't make sense for an instruction to execute like a chip. I'm gonna have like the chip execute the instruction, right? So I'm just gonna do chip dot. And we'll take a look at those compiler errors in a second. But it says, what doesn't it like? Mapping my key again since I quit. Cargo run CR. Okay. So let's do a little bit of a little macro. I'll find our arrow there. Insert chip.execute. Find our colon, delete to our closing brace. Go to the next line. So that should work. Cool. Neat. So then we'll just move her to our chip. This is also an interesting thing. It's got like a bunch of stuff on here that's not really chip stuff. So pub function execute. This will be a mutable self. So, and this will be an impl of instruction. Won't return anything. And for now, we'll just say it'll just do instruction. And we'll pass in self. Says it doesn't know instruction, so I believe this is use instruction. Alright, it's not a... Interesting. I may not really fully understand how this works. Well, that's a problem. So I think this is a case for generic. Might not even be able to do that. Hold on. Let's take. I'm like not sure that this is possible, so. Oh, okay. I guess I can. Hey, how's it going? Oh man, you guys got me in the. Oh man. Oh, how's it going, guys? I've been sitting here coding alone, making a mess of things. I do need raid alerts. Yes. I thought I had them on. What is happening? Well, I've got follow alerts. It's making no noise though. That's really cool. Thanks for the follow. Stella. Yeah. Are you talking about the Rust emulator already built in C? That's like a really good. Yeah. Hey everybody. Hey, Plural Rocket. Thanks for following. Thanks for following Jackie. Thanks for following Anti 666. Samuel Bagan. Yeah, Anti 666 are you? That's a name. Are you talking about the emulator that is that's already built? It's like built in C. It's pretty old. Yeah, it's actually fantastic, and this is really just a learning experience. This is not a rewrite it in Rust moment, but. Oh, 2600 in general, yes, is also called the Stella. I think that was like its code name or something like this. All right, Togglebit, thank you for the raid. Have a good you streamed like a champion today, so have a good one. Thank you for sending everybody my way. Hey, Shijit, I guess that's I'm. Hey, Kirglow. Yeah, actually, in fact, I can show you some things I'm working on here, or I'm working from here, which is the Stella Programmer's Guide, which is written in 1979, which has all this sort of technical data about the Atari 2600. Yeah. Am I willing to play Halo 2600? You would not believe how bad I am at games like Halo. Um, yeah. Um, I I like games that give me time to think in between because I'm not very fast at like anything. So I was actually trying to figure out, and maybe somebody in chat knows without me like doing too much searching. I have a bunch of structs that have not member functions but associated functions, right? that I want to call from somewhere else, and I want to take like the impl of the instruction, and I want to be able to call, like I want to be able to like just essentially pass the type. I don't know how to do that, but so I was thinking if I instruction instruction. Thank you for the follow, Game Usinolo. I'm very good at pronouncing people's names. It's a skill of mine. So the best I could get to is like you can just pass the thing. So if I had a, let's take a look at this playground. So container, it's a trait, it's type item, container item. Okay, that's not actually super helpful. C is a container. I don't think that works. Maybe it does. Do I need an impl? Yeah, I don't think this is gonna work. So I'm gonna actually back off of this and do something more interesting. Basically, what I was doing is like trying to invert the sort of control of how this is happening. Yeah, Rust is hard. There is almost certainly a way to do this, but I will take a look at it later. But in some ways, Rust is easy too. I definitely prefer the upfront cost of learning Rust to the endless sort of debugging, and you still get like plenty of good debugging time in Rust, but at least it's not because you like mistype something and nothing is there to tell you. That happens to me all the time. So. So I will go over with everybody, and I'm not here for super long, but I will go over with everybody what I have done today so far since I've been going for a little while. Hold on while I remove this. I today moved out this sort of timer function I have that basically allows, yeah, that's Telescope. This is like a brand new setup for me. Yeah, I started from scratch, which is why like I didn't even stream for like a week while I was getting sort of my setup going, because my work computers are all Macs. Yeah, Telescope's awesome. My work computers are all Macs, and I have like a very, very old crusty Vim config that I've like shoehorned into NeoVim, and I've got like a bunch of old unnecessary configurations that I don't know about or care about and stuff like that. And I was streaming, but I was using that config on a Windows machine, and it just felt really janky. And so now I am on Arch, by the way. And I am I stole, where's my unless you steal somebody else's configuration, just run with it, which is what I did for a long time. And now I have a lot of time on that one. Yeah, I feel like Emacs is even more that way. It'll drag along crusty config forever. Yeah, I don't know that I would have dared start over if I was an Emacs user. So anyway, I was doing this. I'd built a timer, but there were some bugs in it. And basically what it does is it takes the amount of time that, so I'm like running through instructions, and they each take a specific amount of time, sort of depending on like what they do. And I was I like built a thing and I said like, yeah, we should sleep this long, and then like figure out like how long we went over, and then and sort of batched them together, since like it was um, each instruction was like, I still have my scratch buffer, man. Numbers are not, yeah, is like 837 nanos per cycle, and that was too short for any reasonable amount of for any reasonable sleep. Even I'm using spin sleep, which does some magic behind the to be more accurate behind the scenes. We'll see if I peg my CPU eventually. That may have to be dealt with. But the problem was is that when I was down to 10 cycles or so, occasionally, pretty reliably, spin sleep would run over by so much that I would get an underflow on this calculation here of how long I should sleep. So I actually pulled in something called a fake clock, which does not support times less than a millisecond, which is fun, but basically, what was that? Where was I? Oh yeah, to sort of drive out like if it pauses for too long. So I like set the run over for too long and then subtracted it. So basically, the logic there now is if the run over is less than actual, you just subtract it to calculate your next sleep. Then you calculate your next run over. Otherwise, you just don't sleep and count down the run over, right? So that gets us a pretty stable sort of. Did I change something? Yeah, okay. I bet. Yeah, and then sorry, this music's a little loud in my ears. I'm gonna turn it down in my ears. If it's too loud in the chat, let me know, or in the stream, let me know. Um, so when I run the thing, I'm going to get some debug output about how long it took. This is in nanoseconds, and how many cycles I had until I got to this instruction that I don't know. So if I open my calculator and 7,677 divided by 2,526, and you get something very wrong. I must have added an extra 2. Yeah. You get 842, which is just a little bit over the actual, like, per clock cycle, which is a little bit over the actual. I haven't really looked into that. I'm guessing that's I'm guessing that's sort of the time, like after it's done running, like running that last instruction that it doesn't know, so it doesn't like update the counter and stuff, and then panics out and prints some stuff. So I'm sure there's some. There's a dog under my feet. Cool. So then I was like, I've got all that going, and basically, if you haven't seen it already, I have this debug runner, which I just fixed, which shows you the state of sort of all the flags, instructions, and stuff like that. And you can see that the next instruction was 8A, and it stopped there because we haven't implemented 8A. Oh boy, I need to. Okay, you're putting me on the spot here. Di- Dial, thanks for subbing. I feel like I'm gonna reuse one because I think it's so funny, and my wife does not love it. But I was doing an announcement for work, or like a demo for work like a week ago or something like that, and it was like a recorded video. We're entirely remote, and they needed an answer to a very simple question, which was yes, basically we could do this thing. And so like I recorded it and played it back, and I said in this list of other things that we had done, I said, and we answered the question, it's like, does this API support search? The short answer is yes. The long answer is yes. It was a hit. Thanks. I have more. I just need to. I'm gonna start writing them down, because that's the only one I can remember right now. But next time. Okay, I'm gonna skip this. Actually, I don't have the controls, so we're just gonna listen to it. This like weird acapella version of "Take on Me." Um, Okay, so actually we can. So I was gonna just do some refactoring, and then I found out I don't know Rust as well as I think I do, which I think is sort of the state of pretty much every Rust developer. And so I think we have time to sort of start on the next piece, which is going to be implementing a timer for this thing that lives in the. Right now, it lives in the memory map. It's called the riot, which is the input it. It probably stands for something. Let's see. I bet Stella says something about it. TIA, television interface adapter. That's easy. The PIA, the something else interface adapter. Oh. Okay, now I'm getting to love this version of Take on Me. I hated it at first, but okay, maybe they don't call it right. Are you guys hearing the music? Oh, okay. It's amazing. Um, I think I can't switch over to that. It's on the same screen, so it's like I only have one big screen, so I don't think I can switch over there. Kronborg, thanks for the follow. Somebody else. Marco Marcus Soliveria Vera. Totally wrong. There was an attempt. Is this going to be my thing? Is that I poorly pronounce everybody who follows me? Thanks for the follow, Marcus. I appreciate it. So I'm not finding stuff about the riot chip. They may not have called it that. Let's see. They called it the PIA apparently, because that's what this is. It's got the RAM. Okay, so I don't know what riot means. Probably something to do with I/O, RAM, I/O, and timers. Ah. Are you a streamer anti 666? Okay. Anyway, let's get back to actual code. So I had commented out a piece of code. Where was it? Here. This stuff. Right. So we're going to talk about the timer here. So the riot, or the PIA apparently, as they call it. Like Lion, thanks for following. That one was easy for me. All right, later, Dolly. Dial. Yeah. Okay. Um, so the PIA, or the riot, it's more commonly called the riot, is sort of memory mapped to the chip, and it handles the sort of working RAM, which is only 128 bytes, uh, and it handles some input and output, and some timing. And so what we're dealing here is with timing. So this is the code. I think this is, yeah, for the timer check, which is a read that happens on a timer, and you set a timer by basically by writing to a specific place in memory, and it takes the value of some buffer and multiplies that by by the number of clock cycles that you need to wait until that timer reaches zero. So and then I think that we'll see. But so I faked out writing here, and there's just like a buffer, and that's not how it works. It actually does something when you write to it. But earlier in the program, we wrote to a timer, and now the program that I'm trying to run, we're sitting here waiting, polling on this timer, and to make it more realistic, I made sure that it never returns zero, because that means the timer is done. The problem with that, and it's actually not a problem, it's like exactly what we want. Something is very wrong. Well, I just added that, didn't I? Execution took longer than it should have. Maybe it's because... Might turn that off for a second. It's this. Let's do a little bit of debugging. I thought we were going to do something a little more interesting, but if elapsed is greater than duration, so it will panic, so I'll just say that could use a snippet. Called that. I did not need to. I think that's the only place I'm using it. Okay. So we're going to go over to our memory map where we're causing that infinite loop. Turn this back on. And run it. So something took 56 microseconds. I am unsure what that would have been. So we can go back to our old... Let's get a temporary fix for this. I think it may just be that I'm trying to run them too fast. So if I run 40 at a time. Yeah, okay. I need to tweak that a little bit. I was trying to run 10 cycles at a time, but it seems like I'm sometimes getting... Maybe because I'm in a busy loop, eventually something happens that kills it. I'll have to take a look at that. Regardless, or needless to say, we are in a loop there. And that's because the timer isn't actually being run down, so... So I think what we're going to do here is we're going to just kind of stick this in where we can. I don't love that this is like... that this memory map sort of holds on to this stuff, but I think we'll be okay. So we're going to make a struct called Riot. Struct... which is fun. And as far as I know, we won't implement anything on it yet. And instead of just like some memory here, we're gonna actually make that a right. So call new. Actually, we won't do that yet because we don't need it. So we'll just initialize it like this. Okay, and then we should have some errors. There actually should be some stuff that doesn't work. Like in writing, right? Okay, so instead of doing this, we're going to do self.riot. This is... I don't know if I need it as U size. I think it's fine since we're not indexing. Saying no method name, right? For string? Whoa, string. That's not a string. Struct. Yeah, this is going off the field, so we'll just import that. Right. Adder. We'll take that as a U16. Candidate right is not, method right is not found for this. Yes, it is. Okay, so let's run it again. I'm sure something will say. Right, we need take a self here. Oh, interesting. Okay, so yeah, since we're doing index mute, I wonder if I box myself in a corner here by implementing index here. So it like wants me to give something back that I can write as mutable. So I think I either need to abandon the index mute or implement it for riot. I think I'm going to implement it for riot. Same way I'm implementing it here. Right. Oh man, we've got a couple. 0 volts. Thank you for following, Lucas. Thank you for following. We haven't had any names that I could butcher recently, but I could try. Lucas. Thanks for the follow. 0 volts. I'm not very good at mutilating names, apparently. Okay, so what it's saying here is that it doesn't. This riot struct needs to actually implement index mute. So it's going to be similar to this, which I can probably take all of that. Just looking at something real quick. Okay. So then we're going to do something very similar to what we're... Then I need to be able to give up. I may have myself in a corner here. So index mute just gives you a piece of something, and then yeah. So basically, what index mute wants for you to do is to like give a mutable reference to something that it can then assign to. So I think I'm gonna have to nuke index mute, which is a bummer because there's a lot of stuff in it. But I think I can just pretty easily replace it. Unless I can think of a way to, like, because can I return? Not, like, I can't return it. I need to do something with that value once it's assigned. Let me just take a quick look at the rest docs for index mute. Yeah, so that's a bit of a bummer. I would need some way to like tell what was assigned. Yeah, so I was being a little too clever for myself here. I'm gonna have to undo that. I was trying to make the memory map readable and writable like it would be to the chip itself, and it is like a noble goal. The problem is that like with index mute, I have to give out a reference to something that can then be changed. The thing is that this is going to have an action on the right. It's not just going to like change a value. It's going to actually do something. Like in this case, we're going to set a timer for it. And the thing is, I can't really think of like a way to. I'm gonna go just a little down the rabbit hole. Assignment. Yeah, that would be crazy if you could actually overload assignment. So, yeah, so I think I need to back the train up and get rid of index mute for all of this stuff. So that'll change a lot of the code. Let me actually take a look at my new. I have some tools for doing this, so hopefully this won't be as painful, but I just have to remember what I set up for this. Diagnostics. Telescope diagnostics. Okay. So I think if I do comma FD, okay, that gives me everything in my diagnostics buffer. Okay, so I can change this without hurting myself too badly. So we'll get rid of this. Goodbye, index mute. It was nice to know you. So we're just going to implement for memory map. Set at an index, which will be the same, and a value. Which will be a U8, as it always is. Self.output, that's not quite right. I don't think we need to do anything here. We're not going to return anything. So in this case, we're going to just going to have a set. We'll pass this value through. We don't have to return anything here. It says no set. Yeah, I can just. We'll need a lot of this stuff around, but we can just comment it all out for now. And it's saying no set. So let's look at our diagnostics. We should have a lot more problems than this, so I don't think the diagnostics is pulling up all the buffers. Let's see. So this should actually be all wrong, and I'm really surprised that it's not. Let's see what happens when I run the test. Okay. It's complaining that I don't have set for Riot. So that'll be very similar to... Here, we actually have a memory map impl already. Okay, so it's saying that and that, so that's actually fine. We'll just leave it for now. Okay, so that's saying that our instructions are all wrong. So if we do we'll change this to a so we can probably just do a search for this, and then make a macro, change around. Whoa, just mess that up. Let's try that one more time. Okay. Change surround from that to that. And then find that, comma. And I'll delete that. Find that equal sign, then next. Oh, okay, so that's needs to be public. Can't like private type, so that needs to be a public type. Index mute is not implemented for 000. We'll deal with that in a minute. Let me clean up the rest of this. So we don't actually need that anymore. That's fine. We don't need index mute anymore. So we're just gonna not deal with this test yet. We're not gonna deal with this either. I'm gonna think about it later. So this is our memory. So we actually need to be able to like set our memory, but it doesn't have to look like this. So we can do mmap. So we can do our, and then we should be able to use our so let's change it. So QW. So we'll change surround from brackets to these. Find that. Insert that. I don't care about the extra spaces. I just want to go to the next one. So that should work because it'll all get formatted later. Okay. Oh, right, and I did it. I did the wrong one again. So I can do map. So let's do our comment FT again. Test set out of bounds. Set chip mod unused import instruction. Oh yeah. To figure out what that test is that's failing. Well, this is not exactly what I was expecting to do with my raid time, but thank you for those of you who've stuck around. I think once I clean this up, I'm gonna move us on to somebody else, but this has to get done. Okay, so I actually want to look at that with my so that is coming from memory map 49-ish. That should not be happening. What test is that? Memory round trip. Memory round trip. Where in the test is that happening? Guessing 130 or 134. 134. So why is it saying for 000? Because it's going to break everything. In fact, we can see that it does break everything by running cargo run. Yeah. Am I insane? That's a U16. It should have the value 80. Why is it showing me that it has... something about index? Oh. Because I commented some stuff out. I'm still not sure why it's showing 000, but let's see what happens if I... Okay, I'm back to where I was. Okay, that makes sense. Okay, so if I go to my memory map and then... I'm always returning 1 here. Yep. Always returning 1 here. Undo that, and then Hmm. Okay, so that's fine. Okay, so that's actually fine. When I'm running, so that's actually a real problem. So set's not implemented for 296. I don't know where that would be. That is a timer. Oh, I think I was just sort of like, okay, that's a real thing I need to implement. So we can actually look at the riot addresses, and here's like somebody listed out a bunch of them. Whoa. So two. Okay, disable the timer interrupt and set the timer for a 64 cycle interval. So that's happening somewhere. Um, let's see. I think I have that mapped in. This is actually stuff I need to implement. So not stream. Yeah, streams. Tic-tac-toe. Nope. Includes. We want that. Alright, so that's Tim64T, which is probably used in that code somewhere. Source. Walrus, thank you for the follow. You are joining us towards the end of our stream. So it's not there. It's probably in. Source. Probably here. Okay, so it's actually at the beginning of the vertical sync. So we actually do have to deal with this. And it's 296, so we can actually go to memory map. And then where riot is. We will say so let me make sure something here. Did I do something? Yes, So I've only got the last. Let me see, 9 sixes, 8 is that. That's 9, and then 4 plus 2. Right, so I actually can just look for 1 6 there. Thank you for the follow, Miguel. How's it going? I'm just sort of wrapping up here, but I might be able to get like one more little thing ticked off. So we're just gonna do. Oh, interesting. So we're actually falling through on 286. We're not getting caught in the right. I have something wrong here. So if let's see what the TIA looks like. Okay, I think that's okay. So it's just saying that this bit isn't there. And these bits are. So what are those bits that are there? So we have 0010. No, that's and 1000. So the address we're trying to reach is 296. So this seems wrong then. Let's see that. It's not 4. It's 2. 2 and then 9. Right? Let me make sure I'm looking at the right thing. To set a right timer. Yeah, I just probably copied the wrong thing over. So, and then it's this bit here that I don't think I care very much about, but actually we can just do that. What is that? That is 4. So. Oh. Wait, is that right? In fact, it 2. 8 plus 1 is 9. This is 4. So 294 is the. Oh, we're at 296. So 296 will be. Our mask is 294, but 296 will be. will be 2, 9, 4 plus 1, or plus 2. So yes, that should get us in to riot set and not implement it again. So I didn't finish this. Setting the clock timer. Those are my tests. Memory round trip failed. I'm not super worried about that right now. Set not implemented for 296. That definitely should have fallen through. Maybe my first part of that isn't correct. So we're just saying that top one is not set, which I do think is actually correct. Yeah, so that's correct. Run that and see what we're getting. We're going to probably get a ton of values. No. Oh, okay, we got there. Oh, we need to return from here. That's why. We know why the execution is taking way longer than it should have is coming up. So, and actually I think we can just return set here. We should have, yep. Something very bad happened there. Might be related to this test. Memory map 143. Oh, we need to do this. And we probably just need to do equals value. What is it saying? Oh, yeah. probably might do test pass. Okay, that's the instruction we're expecting. All right. Yeah, so the next thing to do, I think, might be to wrap up for the day. It is 4 o'clock. I've been streaming for 3.5 hours. We might find somebody fun to raid, but the next thing to do, because I wasn't even planning on getting to this stuff today, so will be to actually do something with the internal state of the riot and then stick it on reads. In fact, do I feel like I can do that in a reasonable amount of time today? No, I can't. Let's find who's streaming some Rust if we can. Just me streaming Rust. Why don't we take us over to Bash's co-working?